In this lesson, we're going to review operations with polynomials. You did this back in Algebra 1, and specifically we're going to look at adding, subtracting, and multiplying. For both adding and subtracting, you're going to combine your like terms. Like terms have the same letter and exponents. When you add or subtract, your exponents do not change. For addition, you do not need to have the parentheses, you can just drop them. There are two terms with m to the second power. I'm going to add those two, so 12m squared and 8m squared give me 20m squared. I have one linear term, so plus 3m, and then I can add the 4 and the 5, which gives me 9. For my second example on adding, there are two terms that have p to the third. 2p to the third plus 9p to the third gives you 11p to the third. I have two terms with a p squared. When I add 6p squared and 11p squared, I get 17p squared. There's one linear term, 3p, and one constant, so plus 10. Subtraction. The first parenthesis does not have a subtraction sign, so you can write it just as it is. Then I'm subtracting everything in the second set of parentheses, so I need to distribute the subtraction sign. Every term is being subtracted, so that means I'm going to change all the signs on the second set. That will be negative 9v to the third minus minus gives me plus 7v squared, then a minus 3. Collect your like terms. There are two terms that have a v to the third. When I combine those, I get negative 8v to the third. Two terms with a v squared, so combine those and you get 13v squared. Then one linear term, so minus v, and one constant, minus 3. On the next example, again, the first set of parentheses doesn't have a subtraction, so you can just drop the parentheses. The second set, I have a subtraction sign, so I need to subtract everything inside the parentheses. I'm going to distribute that subtraction sign. That changes all the signs inside the set of parentheses. So that'll be minus 30d to the third, minus minus becomes plus 29d squared plus 3d. And then I want to combine my like terms. So a negative 2d to the third and a negative 30d to the third give me negative 28d to the third plus d squared plus 29d squared gives me plus 30d squared plus 3d. You can pause this and try the next two examples. Hopefully you did that. The first set of parentheses I can just drop. The second one I need to distribute my subtraction sign. And then I'll collect my like terms. There's only one term that has a t to the third, so negative 2t to the third. And then I have two terms that have a t squared, so that'll be negative 2t squared. And then I have an 8t, there's only one linear term. And then I have a plus 6 and a minus 7, which will give me minus 1. On the next example, I have 4p squared minus 6p minus 6 plus 8p squared minus 7p plus 4. So you can just get rid of all your parentheses there. And then collect your like terms. 4p squared and 8p squared give you 12p squared. Minus 6p minus 7p give you minus 13p. And then I have a minus 6 and a plus 4, which will give me minus 2. Now let's look at multiplication. I'm going to go ahead and distribute the monomial on the outside into my binomial in the parentheses. And this is then 4y squared times y squared. So that'll be 4, and I have 2 y's multiplied on the outside, 2 y's on the inside. I have a total of 4 y's multiplied together. And then 4y squared times 3 gives me 12y squared. On the next example, I'm multiplying by f and a g. This is f to the 4th, and I'm multiplying it by another f, so now I'll have 5 f's. You add your exponents. You can put 1s on these if you want to. And I have a g. And then on my next term, I have plus 2. This was f to the 3rd, but I have another f, so that'll be f to the 4th now. And I have a g here and a g here, so that gives me 2 g's multiplied together. On the next term, I have minus 3 f to the 3rd, g to the 3rd. And then the last one is going to be plus f squared, g to the 4th. So you're just adding your exponents on multiplication. Numbers still are multiplied. Let's go ahead and look at what happens when I have, here I have 3 binomials multiplied together, and this is a trinomial times a trinomial. We're going to look and see what we do in these cases, and I'm going to use a different color on part of it, so that might be helpful to you. I'm going to multiply 2 of them together first. So I'm going to FOIL this, so that's going to give me x squared. Outside would be 1x. Inside would be 7x. When I add those, I'll get 8x. And then plus 7. And I'm going to go ahead and multiply that with x minus 3. And I'm switching colors because I think it's a little easier to understand how I'm multiplying this with 2 different colors. So every term in the second parenthesis is going to get multiplied with x. So I'm going to write x and then everything in the second set of parentheses. And then I'm going to take the minus 3 and multiply it with everything in the second set of parentheses. Go ahead and distribute this. That's x to the 3rd plus 8x squared plus 7x. Then minus 3x squared minus 24x minus 21. And let's go ahead and combine our like terms. There's only one term that has a cube, so that's x to the 3rd. I have an 8x squared and a minus 3x squared. That gives me plus 5x squared. And then a 7x minus 24x gives me minus 17x. And then I have the constant minus 21. And that's my final answer. For B, I have a trinomial times a trinomial. So I'm going to take the y squared from the first trinomial and multiply it with everything in the second one. Then I'm going to take minus 7y in the first trinomial and multiply it with everything in the second one. And then I'm going to take the plus 5 and multiply it with everything in the next trinomial. Distribute. So this is y to the 4th minus y to the 3rd minus 3y squared. Then I have minus 7y cubed plus 7y squared. And then minus minus is plus 21y. And then the 5 with everything is 5y squared minus 5y minus 15. Let's go ahead and collect our like terms. It looks like I only have one term with y to the 4th. And then my terms that have a y cubed, I have here, here, and it looks like those are the only two with y cubed. So this is going to be minus 8y cubed. And then my y squared terms, it looks like I have one here, a y squared term here, and one here. So negative 3y squared plus 7y squared plus 5y squared gives me 9y squared. And then I have a y term there and one here. So when I combine 21y minus 5y, that'll give me 16y. And then my constant is minus 15. You could do the box method on that as well if you wanted to. Go ahead and pause the video and try the next two examples. Some people like the box method, so I think I will go ahead and show it on one of these. The box method, you'll just make a box. It's just a nice way to organize it. And so I'm going to put x and minus 2 along one side. And then my other terms in my other parentheses will go along the top. And then you'll multiply the stuff that's in the box. So my first term is 6x to the 3rd. And then you can just work across. So plus 3x squared minus 5x. This box is negative 12x squared. This box will be minus 6x and then plus 10. And then you can combine the boxes. 6x to the 3rd. These two boxes you can see on that diagonal are the same, so I can add those. That'll give me minus 9x squared. These two boxes are the same, so it's minus 11x plus 10. And that's my final answer. So that's an alternate way to organize it. Instead of up here on that first step, I could have gone from this step and made a box rather than writing it out and distributing there. You're still distributing within the box. Unless you make your box in 3D, which is going to be next to impossible on a piece of paper, you're probably going to just need to do the first step on your own here. So x plus 3. And then this when you multiply it out, FOIL it, will give you x squared. Outside is plus 5x, inside is minus 6x, so that gives you minus 1x. And then last give you minus 30. And you could do a box on this one, or you can just multiply it out. I did the box on the last example. Let's go ahead and just multiply this one out. So I'm going to take x and multiply it with everything in the second set of parentheses. And then I'm going to take 3 and multiply it with everything in the second set of parentheses. Multiplying this out, I get x to the 3rd minus x squared minus 30x. And then for the second set of parentheses, that'll be 3x squared minus 3x minus 90. There's only one term with x cubed. These two terms have an x squared, so that'll give you plus 2x squared. And then negative 30x and negative 3x give you negative 33x. And then I have one constant, the minus 90. And that completes our notes.